Well, it's a pleasure to have you review the toner, the pickup arm, and I really appreciate that not only you but other end users are really praising the product. It's SAT is a brand making or focusing on analog playback equipment only, specializing in that, and it's a very recent brand, new brand. It was launched actually at Munich at the Munich show last year, so it's less than a year being promoting and the arm and selling it, and it has been received very well, which I'm really happy about that. Yeah, my background is in mechanical and material science. I've been working for more than 20 years for different companies in different industries. No kind of relationship before with the audio industry until just recently, and well, it's a very peculiar industry, I must say, but it's fun to be a part of it. How can it be that I don't have the history, and I'm no legend like Mr. Nishikawa and Mr. Graham in the audio industry and the analog world. But how can it be that being the first product of a newly created company, that it has been so successful? Well, the answer would be that I have used over 20 years of know-how and experience with my work in other companies and other industries, and apply it to develop and produce the arm. So it's not by chance, but it has been a methodical process and approach. Why did I decide to go for an arm and not a cartridge or a turntable? I knew I wanted to do something with the analog front end, but why the arm and not the cartridge or the turntable, which is what most other new companies are working with nowadays? Well, it was because by doing studies of the phenomena which occurs during the playback, the interaction between the stylus and the record, I realized that the arm was the component which would affect most the final sound of the whole system, not by itself, but as a system. If we look at the components by themselves separately, then I would say that the cartridge is the one who has the most effect on the sound. Why is that? Because it is a transducer. It's a electromechanical transducer. So, like a microphone is, or a loudspeaker. So it transforms the signal, a mechanical signal, into an electrical one. And there are many parameters affecting this process, and small change in some of the parameters can give a huge change in the sound quality. But that's for the cartridge itself. A cartridge cannot work by itself. It needs an arm to support it. The idea is to keep the stylus centered on the cartridge, actually, not the stylus, the cartridge centered on the groove, so that it only tracks the information and extracts the information in the groove itself. It shouldn't move at all, because any other movement of the cartridge or the arm is generating also a signal in the motor. Are you following me? I'm gonna go a bit technical, but I think it's nice to go a bit deeper. So, seen from above, we have here the voice coils, and the stylus on top. And the groove is doing something like this. So every time what we want is for the stylus to move to one side or to the other, or even up and down. It's moving sideways and up and down all the time, depending on the signal in the groove. We want it to move relative to the cartridge, and not the cartridge to move relative to the groove, because that generates also in the motor. It generates in the coil generates a signal, and that signal is not part of the signal in the groove, so it's distortion effectively. So any movement of the cartridge is generating distortion, and the cartridge, it moves because of the loads coming from the forces generated from reading the record, but it also moves because the arm is moving. It's deforming because of these loads. Even if they are really small forces, they are able to deform at a microscopically level the material and the components. So the arm and the cartridge itself they have to be as rigid as possible to minimize the distortion, the movement, which is not part of the groove. And that's the key for, I would say it's the main parameter that a good arm should have. It should be as rigid as possible, and at the same time it has to allow, of course, to have movements to go from the outer groove to the inner groove, and also cope with the eccentricities of the records and the warps. But that's very low frequency movements. All these, the other movements deforming the components at a microscopic level are due to the loads generated by the stylus tracking and deforming the suspension. Actually, the loads are generated when the suspension is deformed. In here, where the coils are attached to the cartridge, there's a spring, and it's a wire, in fact, but it's acting as a spring, and it has a damper. And when this is, we say that this is the stylus, and this is the cartridge. When the stylus moves, the suspension is deformed, and that's what creates the loads, the forces. And those forces are affecting the cartridge and the rest of the structure behind. And the same forces go to the record, actually. And that's why turntables with vacuum section are so much better for the final, for the overall fidelity of the playback, because they hold and couple the record with the platter much more effectively than without having vacuum. Even with weights or rings on the periphery, it's not close to the same effect. So that's the explanation why the rigidity of the arm is a key feature, and there's no way you can have a high performance arm without a rigid structure. It goes against physics. The arm is a purely mechanical component. There's no other let's say branch of physics involved than mechanics. So it's a relatively simple or isolated problem to solve, but if you go into detail to see what's happening at all levels, then it becomes really complex. It's much more complex than it might appear but it's the main features to follow, or let's say to aim for, to get a proper design, are really well defined and easy to work with. Do you have any question about this now?